Hey everyone, welcome back. This is video 2 of our Zig series. In the last video we installed Zig, created our first project and wrote a hello world program. If you missed it, go watch that first and we are building on everything we set up there. Today we are covering the fundamental variables, all the basic types and control flow. If switch, while, for. This is vocabulary you need before you can write anything interesting. Let's go for it. And I'm sorry if I'm kind of boring you with all these things because talking is important before we write code so that you can understand all the stuff. Now, let's have a discussion between const versus var. The first thing you need to understand how Zig declares variables. There are exactly two keywords, const and var. Const means the value is fixed. Once you assign, it never changes. In Zig, const is the default. When you are about to declare something, your first instinct should be const. Most things in your program should not change. Var means the value can change. It is mutable. You can use var when you genuinely need to update a value over time, like a counter in a loop or a accumulator. Now we will switch basically how to declare these kind of things. So we are back here. So we do const x I32 is equal to 5. It can be anything. Similarly, it can be const name equal to Zig, like this. Why the error is used a local constant, unused low. Basically, I'm not using it. That's why the error is, right? And then we can use this thing just to print something out, which is great. Now we have seen how we can run Zig. Do you know how we can run Zig? So we can use Zig build.zig, right? Do you used to doing so basically you can use Zig build main so that it should build main. Okay, we are going to use Zig. I think it should be run source main.zig. So basically we are just running the main.zig. We are not building the whole thing up. Remember that if we are able to building up, we basically create zig.out executable file for everyone, which I don't need right now. So I'm just using zig run source main.zig just to run this particular thing. So you see we have created two things with a constant. Now let's do with var. Okay, so var count I32 equal to 0, and it will show an error if I don't use it. So count equal to counter plus 1. Actually it should be counter, and then we can use std debug counter. And now basically if we run this thing out, you will see the value of counter basically, which is basically counter is incremented to 1. This compiles and unfinds, but if you declare something with var and it never changes, Zig actually warns you. It will say that this variable never mutates, use constant. We can check this out. So if we remove this and if we save, you see it actually warns you local variable never mutated, consider using const. And if you try to build it, it should be the error that it should, like, this is not changed, to use const. Okay, let's go back to the code we had and we put counter equal to counter plus 1. Now coming to the slides. Zig is very explicit about the size of every number. There is no just use int and let compiler figure it out. You choose the exact size you need. The type name follows a simple pattern. The letter tells you whether the number is signed or unsigned, and the number tells you how many bits to use. So U8 means 8 bits. It can hold the value from 0 to 255. U32 similarly means 2 bits. I32 means signed 32 bits. So you can go negative. That means minus 2 billion to plus 2 billion. Similarly, I64. There is also something called usize, an unsigned integer whose actual size depends on your CPU. On a 64-bit machine, it will be 64, or on a 32-bit machine, it will be 34. Now what we do is that basically we go to our editor and try to define everything we just discussed. So we come here, we declare constant byte : u8, which can be 0xff. For now I will put it 255. Obviously the error because it not being used. We will try to use it later. Port use 16 and like 8080, and you const means you can use large number, const negative number, basic base which is i32. And if I try to do std dot debug print, I can try to print everything, and I can just do again a zig run. Okay, it shows that there is something wrong with the counter. Yes, I didn't put a semicolon here, and that was wrong. And if you now run this, so basically you see whatever you have defined here. I hope this is clear for you, and I think this is also very easy to understand. Now when we go to the next slide, we will see our primitive data types like called float, boolean, and strings. So for floating point number, they give you f32 and f64. I won't go much deep into this because if you have questions, just ask me. But it means same in exactly same languages. Booleans are same, true and false. String are same, where you can define basically a array to a uint 8 automatically. We will go much deeper into what slices actually in video 7. For now, just know that the strings in Zig are slices of bytes, and that makes them very predictable. No surprise, no hidden allocation. Let's go to this slide, which is called type inference. Zig can often figure out the type without you writing it. This is called type inference. Like for example, I can go here and I would like to go at the end here now, and I do const age equal to 25. And similarly, I can write const temperature is equal to 98.6. You see in both the cases, I haven't written the type. That works fine. Zig infers that 25 is a comp type integer and 98.6 is like a f64. But when you're starting out, I recommend being explicit. Write the type yourself. It makes your code clear to read and makes error messages much easier to understand when something goes wrong. So there is a built-in called type of, and that you can use to check what is the type of Zig inferred. So what we are going to do that right now. I'm going to use const t equal to type of age. Similarly, const u type of integer, std debug print. While I save it, it says something is wrong here. Yes, it should be capital type of, not small. Now we save here and then we done. It says invalid format string. S is a type of compiled error. Okay. Invalid format string. When we are trying to write it, basically we are not able to write t and this because it could be string as well. So what we can do is that instead of doing this, we pass this as empty, and let's see if this can also be inferred. Perfect. Both comp time int and comp time float. So this is what Zig already inferred. And firstly, I was trying to convert, when I write s, basically I was trying to convert them into string, but when I leave it empty, basically, so that Zig just inferred what the type could be. Now, if else in Zig. If else works like you would expect from any language. Let us type an example on the screen. What example we are going to do is that const score u32 is equal to 100. If, let's do it like this. If score is greater than 90, then, oh yes, sorry, brackets are important here. Right. So if the score is 90, then we can do this. Else if we can do this. Else if we can do this. Here we just run and our score is 100, so we get grade A. Let's put it maybe 85. okay, we should get grade B, right? And I think if I put it like 10, we should get whatever the last grade is. So basically the if else work same, clean and readable. Now the important rule. The condition inside if must be a boolean, that is true for every language, exactly true or false. You cannot write if score and expect it to be trustworthy if the score is non-zero. That doesn't compile and sing. So you remember that in C++ we can write if something, and C++ says, okay, if that value is 0, that means it's false, everything else is true. Zig doesn't work like this. So there is no hidden control flow rule in practice. The compiler forces you to be explicit. This is a pattern worth knowing. If Zig, if it's an expression, it returns a value, so you can write this. This means if you can write, okay, I should show you. So means I want to say this, you can write this like const label if score greater than 90, pass or else fail. And this will basically assign pass and fail to the label. Okay. Now we go to our next slide, which is basically switch. Switch is kind of the same which exists, which basically is in every other command. So what we do is that we say const day is equal to 3, and then we can write const name is equal to switch day. And here you are saying we see Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, right? And now we also say std print day and name. Okay, so here what we are doing is that we are printing the day, we are getting the name, redeclaration of the local variable name. Okay, so we can say day underscore name, and we can use save for this, and we can just paste it. Okay, it already changed. Okay, so and we are using the switch case. Switch case is basically the syntax can be different, but it still means the same, that based on which of the day you will get the value towards the right. And as in our case, we should get Wednesday. So let's clear our code and run our zig command, and you see day 3 is Wednesday. Here we are getting this. So I hope you are able to understand the switch case. Now basically we are moving into something called advanced, and this is the while loop. This is the fundamental loop in Zig and very simple to use. So what we do is that we go to the next slide, we say while. So okay, first we need to declare a variable. Okay, where counter u32 equal to 0, while counter is 5, this, and we are done. We need one more, so we put here. And why the counter is spring, redeclaration of local variable counter. Okay, maybe we use the counter one, so we say the counter loop, and sorry, control Z, control C. Yes, just change everything to counter loop. So now everything is a counter loop. So what we are doing is that now you see we haven't declared it as constant, we have declared it as a variable because we are going to increment it. And every time we increment it, we print basically that this, and then counter loop +1, and when the condition fails, we get nothing, like in any other language as well, like pretty simple. So counter 0, 1, 2, 3, 4, 5. The only difference here you can see is that while counter is here, the condition is here, and the increment is just on the right side, and then the actual condition of the loop starts. So, and if you want to use break, basically it will exist a loop early, nothing else. Now basically the for loop. Zig for loops is different from a C-style for loop. It doesn't have an init condition and increment structure. Instead, it iterates over an array and slices directly. So the for loop, which we can see in Zig, is a bit different from the other languages. Now we will see how. So first we need to declare, let's say, an array. Numbers like this, we declare 1, 2, 3, 4, 5, and then basically we declare numbers which will iterate over this, and here we are just printing the numbers. But I will go for 10, 20, 30, 40, and 50. Now I need to close this one as well. I'm sorry, I need one more bracket here, and we are done. So you see for numbers, so there is no increment, there is no condition. So you see this is basically for each loop. It is not a for loop, it's a for each loop. So it will always go over every character or everything over numbers and slices. Now we run zig.main.cpp, and you see number 10, 20, 30, 40, 50. So this basically wraps up our thing. for video 2. So what we looked, just to wrap up, we looked over constants versus var. A const is default, use var only when you genuinely need to change a value. We went through all the integer types, we covered floats, we saw type inferences, how it works as a statement and an expression. We saw switches, we saw switch, we saw for loop, and how does a while loop works in Zig. So this is a solid foundation. In the next video, we are going to look at functions and error handling, which is where Zig starts to feel genuinely different from other languages. And the way Zig handles errors is one of the most interesting design decisions, and we will take it slow. If you found this video useful, please subscribe, leave a comment with any questions. I read everyone. Then see you on our video 3. Have a nice day. Bye bye.